So in this video we are going to talk about the Thevenin's theorem. So what is the definition of the Thevenin's theorem? Thevenin's theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source V in series with the resistor R. For example, let me take a normal exercise. We assume this source voltage has a V voltage and there's a resistor R1 and there's a resistor R2, and here we have a current source and we have some dependent source. So somehow we need to determine the Thevenin circuit, equivalent circuit for this. So we need to determine two big things. The one is the voltage VTH and the other one is the resistor total RTH. These two are the importance. So we can determine the many ways by VTH and RTH. Let's take an example for this. There are specially two types of the circuits. The one is without a dependent source. Without dependent source, and the other one is with dependent source. With dependent source. We need to figure out these two various things, because without dependent source we need to go on a different path, and with dependent source we need to go on a different path. So this is important. First we need to analyze the circuit that have a dependent source or an independent source. Let's take an example. This come from a without a dependent source. And there are, you can see, it's an independent source and it's an independent source. So it doesn't have any dependent source. So the question is, find the Thevenin's equivalent circuit between A and B. For we need to find out two big things. The one is VTH and the other one is RTH. So first we need to find the RTH. That's your priority. If you want, you can find the VTH first. So I can find the RTH. The thing is, for RTH we need to cut down all the independent sources. We need to cut down all the independent sources. So we need to cut down this voltage source and we need to cut down this current source. Sorry, I didn't mention the current value. It's 2 amps. So right, that's all. We need to cut down this voltage source and we need to cut down this current source. How do we need to cut down the voltage source? We can make the voltage source for RTH. We can make the voltage source as a small wire. Without any voltage source we can make it as a normal wire. And here is the 4 ohm here, and here is the 12 ohm here, and then we have 1 ohm here, and it's A, it's B. So we need to find the RTH between the RL, between the circuit A and B. So we need to determine the RTH value between the AB. So what is the 2 amps, this current source? How would we make the change for this current source? For voltage source, we need to make a small line like a wire. Then that same thing, a current source, we need to cut down this wire. We need to drop out this wire between these two. So there are no electrical paths. Then I don't mention this here. So it is the RTH circuit. Then we need to find the RTH value. This and this are parallel, and this is a series with the resistor. So RTH is a 4 ohm. So RTH value is a 4 ohm. Okay. Then we need to find the VTH value. How we need to find the VTH value? So I can raise the RTH. Then the VTH value. What is VTH? Between the RL, what is the source voltage is the VTH. So we need to draw this again. So for VTH we can't take the source voltage or current source, independent source. We can't. They are always there. 12 ohm. And here that is the current 2 amps and it's 1 ohm. So it's A and B. So we need to find between this. So VTH is equal to VAB. So it's VA, it's VB. Let's assume it's VA. There is no current pass here through the 1 ohm. So it also VA. It's VB, it's a wire, normal wire, it's VB. So it's VA, it's normal wire, it's VA, it's VB, so it's normal wire, it's VB. Then we need to find out in here what is the mesh current in here. We can solve it very easily. So 2 amps. So this is one I1. I can say that in here 2 amps. So I can put I2 here. Then I need to figure out the I1 comma I2. So I can use mesh analysis. So apply KVL to mesh 1. What is coming here? Let's start from here. Minus 32 volts plus 4I1 here. Then here 12 I1 minus I2 here. It's equal to 0. Then we can easily solve that 32 volts is equal to 16 I1 minus 12 I2. So we know from here I2 is equal to minus 2 amps. So we can put it here. So I1 is become 0.5 amps. So I1 is become 0.5 amps. So VAB becomes 0.5 amps into 12. It's 6 volt. It's 6 volt. It's VAB is equal to 0. No, this is not correct. So I can raise from here. Yes, that's. So VAB is equal to 12 into I1 minus I2. So 12 into I1 is equal to 0.5 amps. Minus I2 is equal to minus 2 amps, so plus 2 amps. So 12 into 2.5 is equal to 30 volts here. So VTH is equal to 30 volts here. So the Thevenin circuits become as 30 volts and the resistor series with 4 ohm is the Thevenin circuits. And here we can have the RL. If the RL changes, we can easily determine the values of the current or V0 or somehow. That's the. Let's take another example with the dependent source. How we can solve with the dependent source? Let's see. It's a dependent source. It's a current. It's a voltage dependent source. So how we solve the voltage with voltage dependent source? How we apply the Thevenin's theorem? So we need to find out two big things. The one is the VTH and the other one is the RTH. So VTH is same as the without a dependent source. So we can easily solve without a dependent source. So VTH in here. So VTH is equal to VAB. So VAB here VAB. So it is, if we assume it's VA, it's VB, it's VB because it's normal wire, it's VA because there are no current pass here. So we need to determine between the 6 ohm resistor the voltage, so it's equal to VTH. So let's assume we can put its I1 and I2 and I3. So we can make that using mesh analysis, apply KVL to mesh 1. So that's not need. I1 is equal to 5 amps. We can directly find from here. Apply KVL to mesh 2. So we can find from here minus 2Vx plus 2 into I1, I3 minus I2 is equal to 0. So here is the first equation, and the apply KVL to mesh 3. Apply KVL to mesh 3. We can find from here 2 into I2 minus I3 plus 6 into I2 plus 4 into I2 minus I3 is equal to 0. We can solve from here. So we can get the answers from there. From there, I1, I2, I3 we can solve easily from a scientific calculator. I1 is equal to 5 amps. We already know that. I2 is equal to 10 by 3 amps. And I3 is equal to we can find, and obviously we don't need the I3. Yes, we only need the I2, so we don't need the I3. So I can put the VTH is equal to 6 into I2, so 6 into for I2 10 by 3, so it's 20 volts. VTH is equal to 20 volts. So for the RTH, how do we find the RTH? That's the important thing. Please concentrate here. For the RTH, we can make a small change here. For RTH, we need to put a 1 volt battery between the A and B. We need to put a 1 volt battery between A and B. The other things are normal except the independent source. For the independent source, what we need before without the dependent source? Yes, for current source we cut down the dropout our wire. For voltage source we make a normal wire for there. For in here also we need to cut out this because there is the current source. So there are no amps here. Then here it's a 4 ohm. And here is a 2 ohm, and there is a dependent source. We can't make any changes for dependent source. We need to mark only the independent source. So it's 6 ohm, and that's it. So it's 1 volt. For RTH, V is equal to IR. Let's assume for this current is I naught. So 1 volt is equal to I naught into RTH. So RTH is equal to 1 volt by I naught. So what we need? We need to find the I naught here. We can put here, in here I1, and in here I2, and in here I3. We can put the mesh analysis here. Apply KVL on mesh 1, mesh 2, mesh 3. We can put the KVL. It's also very easy for you. For the RTH, we can get it. I1 is equal to I2 is equal to I3. We have 3 equations. We can solve easily from a scientific calculator. I3 is equal to minus 1 by 6 amps. I2 is equal to, but not necessary I1 and I2, we don't need to for that. So I naught is equal to minus I3. From here, I naught is upward, I3 is downward. So I naught is equal to 1 by 6 amp from here. So the RTH is equal to 1 volt by I naught, so 1 by 6. Then 6 comes there. So 6 ohms from here, and RTH is equal to 6 ohm from here. So we can say that for this Thevenin's theorem, we put 6 ohm RTH and the 20 volt VTH. And in here, what you want, we can connect from here. So in this video, I think I can give a brief explanation in the Thevenin's theorem and the examples. So the next video, it's coming up with the Norton's theorem and superposition theorem. For that, for more electrical videos, please subscribe and like our channel. Thank you.